So hey everyone, this is Yas, and today I'm gonna show you Codeforces Round 1009, which is Division 3. So I have solved a couple of questions. So here I'm gonna show you some of the solutions. And the first question, let's jump to the first question, which is a draw a square. Okay. So we have time limit per test 1 second, memory limit per second 256 megabytes. So let's see what question says. The pink soldier has given you 4 distinct points on the plane. The 4 points coordinates are higher like minus L, comma 0, R, comma 0, 0, comma minus D, or 0U, corresponding where L, R, D, U are positive integer. Okay, so if you put this in the form of graph, we'll be getting like kind of this graph or mathematical something like that. Okay, so let's see. Please determine if it is a possible to draw a square with the given point as its vertices. So let's see what it squares is like. Okay, so a square is defined as polygon consist of 4 vertices of which all sides have equal length and all inner angles are equal. No two edges of the intersect each others. Okay, so let's see. Input each test case contain multiple test cases. Okay, like t number of test cases. The first line of each test case contain 4 integer LRDU. Every test case contain this LRDU values. Okay, so output like for each test cases, if you can draw a square using the 4 point, output yes, otherwise no. So you can output the answer in case, for example, there's yes, and this is the form of like what we are gonna output. Okay, so let's see. We have some input too, and this is the array LRDU values. Same, this is the second LRDU values. So for first it is saying yes, and for first it is saying no. So what is question? She's like okay, so it says like LRDU. It is forming like a you can say square. Okay, if it is forming square, you have to return yes. Okay, so just think of it like just take an assumption when it makes the square. It makes the square when like we have LRDU. Okay, we have like all the things like all these four will have same values. Okay, then it will make a proper square. Okay, if like one value goes like little bit of different, it will make something like, let's suppose the u value is 2. Okay, and as you can see, this not looks like a square. It's kind of a rhombus. So like for a square you need like LRDU should be like same. So you just need to check if LRDU are equal. Okay, just need to check if it is equal, return true, or yes, as written no. So this should be your solution. So let's see our solution, what we done. Okay, so there's nothing, just like say hi or just like sync with the studio cn.i. You don't need to look at this. Okay, just see it like cnt. So this is the number of test cases we are taking it. So while t minus 1, so we'll inputting LRDU and we'll checking like if it is square. Okay, LRDU. Now what we are doing, we are using set is a data structure. Basically whatever we put inside the set. Okay, let's say we have L value 2. Okay, we have all the value LRDU 2. So when we put a value inside set 2, okay, if 2 again comes, it will not replace it or not will make it duplicate. It will have same number of occurrence. Okay, 2, just one occurrence. Again d value 2. Okay, again u value 2. So in the last, if the set dot size is equal 1. Okay, if it is equal 1, just return true. That's it. It's and if we return true, just print yes or else no. So this is the solution. Okay, so let's look at the second question. We have the third side. Okay, let's see what is the third side. The winged soldier have given you a sequence a consist of n positive integer. You must really perform the following operation until there is only one element left. Choose two distinct indices I and j, then choose a positive integer value x that are exist a non-degenerate triangle. Okay, just remember this word. Okay, non-degenerate triangle. Okay, so with side length AFI, AFJ, and X, finally remove two element AFI and AFJ and append X in the end. Okay, please find the maximum possible value of the only last element in the sequence A. Oh, okay, so let's see. A triangle with the side of ABC is non-degenerate when A plus B is C. So we'll check this condition later onward. Let's see the input like again t test cases we have to take. The first line of each test case contain a single integer n, and the second line of each test case contain n integers. Okay, whatever n we'll putting, like we have to take that input, okay, in the form of integers or like array vectors, whatever. Okay, so it is guaranteed that the sum of n over all test cases should not exceed 2 into 10 power 5. So it can go till n log n, so we don't need like we should not solve in n square. Okay, so this is the test, like we have the times. So let's see the test cases. Output for each test case, output maximum possible value of the only last element of separate line. So we have input 4 1 10. Okay, so we have taken four like test cases. So the first test case 1, so for 1 we have input 10, for 3 we have input these 3, again for 5 we have input this 5. Okay, let's see how we can solve this. Okay, let's see one solution. On the first test case there is already only one element. Okay, so there is one word before we should know, like before looking at these solutions we should know what that word. Okay, non-degenerate triangle. Okay, what it says, like non-degenerate triangle is a triangle where all three sides satisfy the triangle inequality theorem. Okay, meaning it has a positive area and non-collinear vertices. Okay, so like for 3 a comma, okay, so let me explain you, like, okay, so a comma b comma c. Okay, to form a non-degenerate triangle they must satisfy like a plus b is greater than c, or a plus c is greater than b plus c is greater than a. So like if any of these inequalities like fail, okay, the shape which say become like degenerate, or meaning it collapse into a straight line with zero area. Okay, so there's a thing we should know, like what it is. So okay, so let's say on the first test case there is already only one element, so the value of the only last element is 10. Okay, so there is only one element, so we'll return only one element 10. So the second we have like, okay, so the second we have like three element. Okay, 998, 244 and 353. Okay, so let's see if we can combine this both. Okay, 244 plus 353, it's still like less than 998. Okay, still less than 998. Okay, so like we can we append it? Okay, can we append? Let's see. On the second entry, initial 998, 244 and the following series operation is valid. So a2 is 244, 353. Okay, we are considering these two value and append. When we append this both, we will be getting 596 to the end of a. So a is now 998 comma 596. Okay, this is the value, and if we combine again this both, we'll be getting like 1593 to the end of a. So the final value is 1593. So this we have the solutions. So it can show that the only last element cannot be greater than 1593, therefore the answer is 1593. Okay, let's see next. We have next like we can see the solution now. So like the number of test cases we are taking input. Okay, so we have n value, then like we have vector storing the values in the form of vector. Now what we are using priority queue here. Why we are using priority queue? Like we are just like the top element. Okay, so we are like, if the priority queue size is greater than 1 t. Okay, so it means that we have multiple elements, so we can use like int x equal to pq dot just take the top element. Okay, if we take the first top element and the second top element, we'll just add both the value. Okay, if we will add both value and then we'll decrement by 1, and that thing we will push inside the priority queue once again. And similarly, like while it is greater than 1, okay, we will be doing this repeatedly. Okay, and at the end we will be returning the pq dot whatever like we have remaining at the last moment, we will be returning that. So let's see one try run from this code. Okay, so we have like 1 2 3 4 5. Okay, so we have like 1 2 3 4 5. As you can see, this is a max heap. Okay, you know how we know that it's max heap, like because we are using like just priority queue, not anything like inside the parameter. We are not using greater or something like that. For minimum priority queue we need that parameter. So let's see 1 2 3 4 5. So at the top we have like, let's push 5 4, and we have like, okay, we have like 3 and 2. Let's suppose we have this kind of tree. Okay, so 5 plus 4, it will be like 9. Okay, so 9 minus 1, we will be having 8. Okay, so now our tree will be like, okay, tree will be like 8 3 2 1. Okay, now the top two element are 8 and 3. 8 and 3, how much? 8 and 3 again, 8 and 3 plus 1 minus 1, so this is equal to 12 or 11. Okay, 11 minus 1 will be having 10. Okay, now it's like something like 10 to 1, something like that. Okay, so the top two element are this, so it will be 12 and then -1, so we'll be having 11. Okay, so 11, and now we'll append 1 here. Okay, so 1, so 11 1, which is equal to 12, again -1, which is equal to 11. So our final answer is 11. As you can see, this is the answer. So this way we are gonna solve this. Okay, so there's a solution. Okay, so we can check the C quotients. Okay, so we have C quotients or in triangle. So this time the pink soldier has given you an integer x, which is x should be greater than or equal to 2. Please determine if there is x with a positive y that satisfies the following conditions. Y is extremely less than x. There exists a non-degenerate triangle. Again, non-degenerate triangle, same as the above, with side length x, y, and XOR. It's XOR signs. Okay, so here XOR denote the bitwise XOR operation. So this is nothing like if we have a is equal to like 110. How much is this? 2 4, it's equal to 6, and we have like b equal to 001, which is equal to 1. So we know that XOR of this, what is this? 1 which is equal to 7. So like if we have like different value, it will be like the XOR of this is 1. If we have same value, okay, so XOR of this will be 0. Okay, so we can see that additionally, if there is exists such integer y output any. Okay, so a triangle with side length ABC is non-degenerate when a plus b is greater than c, a plus c is greater than b. Same, this is the degenerate triangles identity, you can say that. So we have to take input. So again, the test cases, only line each test case contain a single integer. Okay, x. So let's see how we're going to solve it. So output should be like, for each test case, if we enter one integer on a separate line, the integer you must output is following. If other exists on integer y, satisfy the condition output of the value y, otherwise output -1. So we can check like for these are some inputs. So 7 number of integers we are taking. So first is 5. For 5 it is getting 3. Okay, so let's see how it is getting 3. So in the first case, there exists a non-degenerate triangle with side of length of 3. Okay, so if we XOR 5 with 3, okay, we'll be getting like 6. So as we can see, 6 we are getting. So therefore y which is equal to 3 is a valid answer. Okay, so that's the thing, like we should know how we're gonna solve this. And in the second test case, like 1 is the only possible candidate for y, but it cannot make a non-degenerate triangle, therefore the answer is -1. Okay, so let's see the solution. So we are taking like the number of test cases. Now input x, this is input x. We are checking like is power of 2 if input x, or input x plus 1 is power of 2. So how we are checking power, just like this is like if like num should be greater than 0, and like if it is like if the end operation of num and num minus 1 is equal to 0, it means that it's a power of 2. So it will return 1, and we'll just print -1 and continue. We'll just skip that part. We'll just go for the next test cases. Okay, so if it's not the power of 2, so we are just declaring largest power, which is equal to 1. So why largest power into 2 is less than input x. So let's see this example. Okay, how we are getting 3. Let's see how we are getting 3. Okay, we'll show you. This is 5 here. Okay, so let's suppose we have 5 here. So as you know, this will not come here. Okay, 5 will go directly here. So 5 into, so largest power is initially 1. Okay, 1 into 2 is less than 5. Okay, so now largest power is equal to 4. So 4 into 2 it's 8 is less than equal to 5, which is true, which is false. So inside largest we have 4. Inside largest we have 4. Largest will come down, like will come down. Result of y equal to largest power -1. So result of 5 equal to 3. Okay, so this is the value we are getting of y, and we have x equal to, as you know what we have, x 5, and we have like result 3. Okay, let's see if we'll do XOR of both value. Okay, so 0 0 1 1. Okay, this is 3 value, and 0 1 0 1. So let's see if we'll do XOR of this, we'll be getting like 0 1 0 0, which is equivalent to 2. So this is the XOR value. Okay, okay, so there is one mistake that I have done. Largest power -1. This is then we'll be printing XOR value 2. So 0. Okay, so there is a little bit mistake I did. Okay, so the mistake which I did, like 0 1 XOR it is equal to 6, so this is coming 6. So as you can see, we are getting like 6. Here we'll be getting like XOR value of 6, so which is like, as you can see, 3 XOR 4 5 is 6, so therefore y is equal to 3 is a valid answer. So it follows the identity. So if it is follows the identity, we will be like giving the, we will be just like returning the value. Similarly, you can do this for like 2. Okay, as you know, this is the power of 2, so it will definitely return -1. You can see that you can do this for 6, we will be returning 6, something like that. So this is the logic we are going to follow. So, and there's one more question, so like you can do this question yourself, or you can check any YouTube. This question is hard to explain, so we'll try to make a new video for this question. So okay, thank you.